Hey, Algebra 2 friends, here we are in Chapter 12. We're looking at Section 12.3, probability. All right, guys, let's get to the vocabulary. So here we are. We're going to talk about probability. And I think you guys know what probability is, but the best way to talk about it is to use an example. So for instance, what if we had a gumball jar filled with green, red, and purple gumballs? And I'm not quite sure what the flavors are, but let's not get into that. Let's just talk about the situation. So we've got 15 green, 12 red, and 13 purple, whatever color that is. And so when we talk about probability, we're talking about outcomes, and we're using phrases like that. But basically, we want to know the ratio between a desired outcome between all the possible outcomes. So for instance, if I wanted to know the probability of picking, let's say, a red gumball, it would be the total number of outcomes at the bottom. And if we add up all of this, we'll see that there are 40 gumballs altogether. So that's the total number at the bottom. And at the top, we would get the specified or the desired number of things. And so that would be 12. So the probability of picking a red gumball at random from the jar would be 12 out of 40. And of course, we can reduce that so that we're dealing with 6 out of 20, which then reduces to 3 out of 10. So that's the probability of me getting a red gumball. So in a sense, when we talk about the idea of a success, let me go ahead and highlight that. If we talk about a success, it's the desired outcome. It's another way of talking about the desired outcome. And of course, if we talk about the failure is all the ways that that desired outcome won't come through. So imagine this situation with the gumballs again. What would be the failure? Well, the failure would be if I picked anything other than red. And so that value would be 40 minus 12, right? Which is going to come out to 28. So in this case, 28 out of 40 is the probability of failure, but the number of failure options would be 28, while the number of success options is 12. Random just means that you have equal chance of picking any of the gumballs or any of the particular different events that can happen. So a random event is something that's exactly as you think. It's random, okay? And so it means that each of these things are equally possible to happen. When you're dealing with odds, this is a different ratio. Do you remember that probability? We just said it. Probability was the ratio of the success, basically, over the total number of outcomes. The way your text is going to do this one is has S over S plus F, right? So the success over the success plus the failure. So that's the total thing. But the odds will be the ratio of the success to the failure. So for instance, in this situation, what's the odds of me choosing a red gumball? That would be 12 to 28. All right, and of course we can reduce that so that that ratio is going to be what, 6 to 14, which is going to be 3 to 7. So that would, and I guess I should have figured that out from this too. Okay, so probability distribution. Sometimes we have charts that will show the distribution of all the possible probabilities. So the current information given down here would be a probability distribution, which is basically just showing you the representation of the probabilities for each of the different variables that we have, which in this case would be the red, the blue, and the green number of gumballs. And so a relative frequency histogram is really, and I'm just going to do a very sloppy little drawing here. It's really just going to be a histogram. Remember, it's pretty much a bar graph that shows how frequently you would get each of these particular types of treats, types of gumballs. So this might be the 3, what would this be? This would be the 3/10, this would be the 13/40th, and this one would be the 3/8, showing that obviously you're more likely to get green based on the fact that there's more green here. All right, guys, now that we've gotten the vocabulary out of the way, let's get some examples together. Oh, to reiterate that one concept that we talked about, the probability of success can be written like this. We talked about it. P parentheses S can be written in this way. And then the probability of failure would be written this way. Again, the thing that we don't want to happen out of the total number of possibilities, or the thing that we do want to happen out of the total number of possibilities. All right, so here's example 1. We're looking at a probability, pretty simple. If you toss 2 coins, what is the probability that both of them are tails? So what we need to think about is, what are the things that can happen? So coin number one. So let's write that down. If we have coin number one, we can have only two things can happen. We can either have heads or we can have tails. And with coin number two, same situation. We can either have heads or tails. So what are the different events that can happen? So let me put this to you in this way. So let's consider this chart. If we were to have two possibilities for each of the coins, then that means either both coins could be heads or one coin could be tails while the other one is heads. You guys get how this is going, right? Either one could be heads and then tails, or the other one could be tails and the other one could be tails. So even though it doesn't seem like we've got four different possibilities, there are exactly four different things that could happen. So when two coins are tossed, what is the probability that they will both be tails? Well, clearly the only way for that to happen is one way, and that's this one here. I'm going to highlight it in red. And so since we know that probability of two tails, I'll just put TT there, the probability of two tails will be, is only one way to get it, and that's out of four possibilities. The probability is 1/4. Another way to think about that is just the idea that one coin, the probability of getting tails is 1/2, and then the other coin, the probability of getting tails is 1/2. And therefore, when we multiply it or we're combining those probabilities, we do that by multiplication. So we get 1/4. All right, let's check out example 2. What's the probability? We're going to use probability with combinations. So Manifa has a collection of 32 CDs, 18 R&B, and 14 rap. As she is leaving for a trip, she randomly chooses 6 CDs to take with her. What is the probability that she selects 3 R&B and 3 rap CDs? So I'm going to write it this way, just so we can keep in mind and focus on what we're trying to do. So think about what we've learned so far. We know that there are going to be several ways to have success, and we need to count all of the other possibilities, which is our successes and our failures. And in this case, basically what we need to know, or what we need to consider, is that we're finding out how many different ways she can choose 6 CDs out of 32. She's not ranking them, so this is going to be a combination and not a permutation, okay? So this value here has to be, how do we write it? 32, choose 6. And so you remember how to calculate that. So what we'd have is 32 factorial over 32 minus 6 factorial, also divided by 6 factorial. And so that leaves us with 906,192. So that's going to be our value for our denominator, or the bottom part, or all the total possible outcomes. Now we need to figure out what the successes are. So the success would be the number of different ways we can pick 3 R&B CDs, and a number of different ways we can pick 3 rap CDs. So that's going to be more combinations. So the combinations that we have for those two different situations would be 18 choose 3 because she has 18 rap R&B CDs, and 14 choose 3 because she has 14 rap CDs. So we'll calculate that, and you guys know how to do it. You've done enough of it in the last section. So I'm just going to pull up the answer for you. Actually, it makes better sense to do it all at one time in our calculator, to be quite honest. So what I'm going to do is I'm going to show you that to calculate this, we're actually going to have to multiply these two values, because think about it. How many ways can we get the R&B value? Will be this number. How many ways can we get the rap value? It'll be this number. But we have to take into account all the possible combinations therein. So we have to multiply those two probabilities. So when we multiply that, that gives us a whole bunch of different choices. Use your calculator. We're going to get 297,024 different ways for that event to happen, for those successes to occur. And so now we can write this as a ratio of 297,024. I hope you can see that kind of squeezed in the corner, and 906 over 906,192. And guys, this is so messy here, but that's going to give us 0.3277 is the probability of her picking 6 random CDs, and those 6 random CDs happen to be 3 rap CDs and 3 R&B CDs. Here in example 3, we're going to be considering odds. If you guys remember, we just talked about that earlier when we were looking at vocabulary. And so odds would be success is the ratio of success to failure. So let's look at this situation. Life expectancy. According to the U.S. National Center for Health Statistics, the chances of a male born in 1990 living to be at least 65 years of age is about 3 in 4. For females, the chances are about 17 in 20. What are the odds of a male living to be at least 65? Now, this 3 in 4 is 3 out of 4, or 3 out of the total 4. So what we need to do is realize that a success is 3, and that the failure would be the other thing that happens. Therefore, it's going to be 1. Does that make sense? So the failure is going to be 4 minus 3, which is 1. Similarly, with this question, what are the odds of a female living to be at least 65? It'll be the same thing. Success versus the failure. So the success is 17. But what would the failure rate be? Well, the failure rate would be the 3 out of 20. So that would be the 3 here. Here in example 4, we're going to talk about probability distribution. Suppose 2 dice are rolled. The table and the relative frequency histogram show the distribution of the sum of the numbers rolled. So if we take a look, what's the probability of rolling 2, the sum being 2? So you imagine having 2 dice. The only way to get 2 is to get 1 on both die. That's 1 out of 36. How can you get 3 if you're, or sum of 3 if you're rolling 2 die? Well, you can get 1 and 2, or 2 and 1. So that's 2 different events that could happen out of the 36, and therefore that's 1 out of 18. You guys kind of getting what I'm talking about? I hope so. But if you notice, there's like a whole bunch of different ways to get 7. So you can get either 1 and 6 or 6 and 1. That's 2 separate events, because one die could have the 1 and the other one could have the 6, or you can reverse that. Or you could have 2 and 5 and 5 and 2 and 3, and you guys get it, 3 and 4, 4 and 3. So there's a whole lot of different ways. So that's why we get the greatest possible number, or the most frequent thing that could happen is that you get a sum of 7, and that's what we're seeing here. So in this question, they asked us to use the graph to determine which outcome is most likely, and you can clearly see that 1 out of 6 is the greatest probability, and so we know that what is most likely is to get 7. So to put a finer point on it, the probability of the sum of 2 dice equaling 7 is going to be 1 out of 6. And finally, it says use the table to find the probability of the sum equaling 9. What other sum has the same probability? So we go up to the table, we see that the sum equaling 9 would be a 1/9 probability. And the other situation that would yield a 1/9 probability would be the probability of rolling a sum of 5. Finally, we're asked, what are the odds of rolling a sum of 7? And when we talk about odds, remember, we're talking about the ratio of success to failure. So how many ways can we succeed versus how many ways we can fail? So the success is, we know, 1 out of 6. Therefore, there's 1 way to succeed out of 5 ways to fail. So the ratio would be 1 to 5. All right, everybody, that's the end. I hope that stuff made sense. If it didn't, definitely let me know. See if you can contact me, or we can wait till we see each other this week. Have a good one. Take care. Bye-bye.